In this episode, I shall talk about the way relativity uses speed and the mass that it uses. Speed is defined by physics as the travel distance in a given time. V equals d divided by t. Special relativity says that light will be measured as invariant c from any inertial system of reference, regardless of the speed of that system relative to the light. This is precisely the same as saying that the light will adapt its speed according to the speed of the objects that happen to be in its path. I say this is not physics, but moody love comedy. Light is personified in a psychotic Romeo. The light will neither fall in love nor get scared of the objects in its path. I say light will keep its speed constant relative to the medium within which it is an oscillation of. The fact that the speed of the oscillation doesn't depend on the speed of its actual source is included in this perspective. A vibe, oscillatory motion of something, medium, depends only on that medium and not on the objects moving in its path that might be 1 billion miles away. Special relativity totally ignores distances. The spirit of fantasy acts instantly and equally regardless of the distance. Let A, Alice, travel at the speed v relative to a stationary source of light P. Say that P is fixed on a rigid bar OP and A travels along OP. Special relativity postulates that if you emit a ray of light from P in the direction of A while A is moving, A will measure the speed of light equals c despite the fact that A is traveling at v in the same direction as the light is. Special relativity is in fact incapable of measuring the speed of light from A while she is moving, the same as everybody else is, including me. But talking is always easier than actually doing, especially when nobody can check. Imagine two photons, A and B, traveling together in a ray of light. Special relativity says that each one will measure the other as traveling at speed c relative to it. That would be photon A seeing photon B moving away relative to A at the speed of light. Meanwhile, a stationary observer measures both A and B traveling side by side at the speed c in the same ray of light. What would be the physical outcome of this postulation? Relativity works. Who cares about details? I will make my own prediction, except that I will make some real measurements. I will base my prediction on the distance traveled by A and by the ray of light when they are moving separately, because I don't believe that there is any sentimental relation between the light and Alice. The drawing is meant to present the distances traveled by Alice and Py traveled by the light in the same time. Let Alice travel for a time t, starting from P, with the light switched off to avoid any psychological trauma. Measure the distance px, vt, traveled by Alice in the time t. Then ask Alice to hide, so she cannot scare the light. And then let the light be emitted from P. Mark the distance Py equals time times the speed of light traveled by light in the time t2 equal t. That is to say, I measure the distances traveled by Alice and respectively by the light during equal intervals of time t, yet traveling at different hours, say 1 p.m. and 2 p.m., such as they cannot influence each other. Special relativity induces the bizarre idea that the light behaves differently when there are other objects traveling in its path than when it travels alone. Now I postulate that when A and light will start simultaneously from P, they will travel in the same time t, the same distances as they did travel separately, because they are not emotionally involved, I guess. Based on the distances they've traveled separately divided by the time t, I can now calculate py minus px divided by t equals ct minus vt divided by t equals c minus v, based on the real physical measurements of px and py. By using the basic definition of a speed, v equals d divided by t, I postulate that A will measure the speed of light relative to her as being u equals c minus v. I cannot really know if they actually fall in love traveling together, and maybe the light will adapt its speed to Alice's speed, in such a way that Alice will measure the speed of light as c, simply because I'm not a magician. I say that special relativity doesn't know the sentiments of the light more than I do. Yet who am I to know magic? My prediction is based on real physical measurements when the two travel separately. Unlike me, special relativity makes its prediction in the absence of any measurement at all, but pretending to be a magician. Special relativity postulates that the speed of light will adapt to the speed of Alice, such as Alice will always measure c instead of c minus v. Question: why would anyone in his right mind assume that light adapts its speed according to the speeds of the objects that happen to be in its path? Assumption based on nothing, out of thin air. It's a kind of magic in this. I'm not precisely sure what kind. This idea is claimed to be the logical conclusion of one totally stationary experiment, the Michelson-Morley experiment. No object was moving relative to the light in that experiment. Now let's take more objects to travel in the same direction, line, with the light. Say A, B, C, D, Z. Each of them at different speed than the others relative to A. Some of them in the opposite sense. Also, the light is described by physics as being photons, which means particles. Let's try to visualize how a particle of light, photon, adapts its speed to be the same relative to many other different speeds. One particle traveling at many different speeds simultaneously. Does it split and multiply? Is the photon a sort of bacteria? Even less it works if you describe the light as a wave. Light, as described by relativity, moves neither as a wave nor as a particle. It moves like a charade. I postulate that such thing is not physically possible. And you might argue, but you are not Einstein. And I will ask, if Einstein tells you that it's night when you see the sun up in the sky, are you willing to accept that it's actually night? Because the smart guy says so? The smart guy himself didn't state he's sure about it. He said it is a postulate, equal supposition, equal assumption, equal I think so, equal I cannot prove it, equal if I could prove it, I certainly would. I tried, but it didn't work. Or maybe it was a bad dream. I say that all the attempts made to prove this delusion in practice had failed. Funny enough, special relativity says that the speed of light is invariant c in the empty space, made of nothing. This doesn't even qualify for the definition of a speed. This is pure verbal noise. It's not even wrong. A speed is to be defined relative to something, a reference thing. Physics, as it is, states that nothing is no thing, as opposed to any thing. That means no reference system. It's the same as pretending to see colors in the total dark. But physics is not physics without equations. But equations without physics are not physics either. They are relativity. The fundamental wisdom these equations are expected to describe is c plus v equals c minus v equals c. But mass is a stubborn, nervous animal. It is allergic to absurdity and kicks back in revenge. How can one force mass into submission? Well, one cannot actually do that for real, but one can hide his incapacity behind a dense smoke screen and present some meaningless derivation as describing what they actually don't describe. C plus V equals C minus V equals C obviously doesn't work. Rather than accepting this to be absurd, one insists that he must be right. If one is right and mass is wrong, then one must correct the error. And that's the purpose of the correction factor, G gamma. One needs to find a correction factor, G, such as G times C plus V equals C, equation 1, and G times C minus V equals C, equation 2. Even if such G would exist, it would rather mean that it's something wrong about the way the speeds are measured. Based on the solid proof that the speeds are not measured at all, one rules out this possibility. Based on these solid proofs, one chooses to assume that, because C is invariant, it must be the distances and times that are variable, and in this way to fix the equations. Distances and time become collateral victims of the effort to fix the equations. Yet, at this stage, it is still a minor issue. There is no such G to satisfy the equations 1 and 2. So, no way for Alice to measure C instead of C minus V, even if one applies any G correction factor. What can one do about this? Nothing real. But one can play with the equations in a physically meaningless way. One can multiply equation 1 and equation 2 and get G squared times C plus V times C minus V equals C squared, which means G squared multiplied by C squared minus V squared equals C squared, and extract G squared equals 1 divided by 1 minus V squared divided by C squared. Now, when one multiplies G squared times C squared minus V squared, one will get C squared. So, what is the physical meaning of this? Alice is supposed to measure C, not C squared. C squared doesn't live in the real world. In the real world, a moving one cannot even measure C, the real physical speed, yet alone something that doesn't exist, C squared. I say C squared is only a meaningless derivation. As it is derived, G fails to fulfill its basic purpose. It was supposed to help one to measure C instead of C minus V or C plus V, or to justify how it works. It can only justify why one would measure C squared. But let's get over this. Who cares about details? The big achievement is that one has now proud, shiny equation. Wow. What can one do with a meaningless derivation? One can play with it. Use it as a merry-go-round, as a bumble-joy toy. One can use it to turn the physics upside down. One can use it even to count ships, as long as V is smaller than C. One can get over the fact that G fails its basic purpose and use it to express how is A supposed to measure from a system A events that happen in another system B, while they are moving relative to each other. It is instantly obvious how could A in a spaceship could measure a rod inside a B spaceship, moving relative to A. Let's say not 1 billion miles away, but only 1 mile away. Through the walls. Like always, forget about details. One can get now x prime equals g times x minus vt, and t equals gt prime, x prime being how a measures the distance traveled by an object moving in B, and t prime being the time measured by B while a measures t. the clock in B is predicted to run slower compared to the clock in A. The minor issue is that when A moves relative to B at a speed v, one can write t from the perspective of each one of them, because they are perfectly equivalent. That leads to the famous twin paradox. Time A is smaller than time B, and time A is greater than time B simultaneously, which I solved in the episode dedicated to time. Mass is allergic to absurdity and kicks back in revenge. The same paradox appears if they compare two equal rods. It would be length A is smaller than length B, and length A is greater than length B in the same time. How can the spirit of fantasy contract a rod without applying a force? Relativity doesn't even attempt to imagine, delude, a physical mechanism in order to explain it. It just so happens, by magic, relativity works. Who cares that it stumbles in its own equations and furiously kicks itself in its own mass? Relativity indeed works. It works like a mathematical reduction to absurdity. You take one assumption that you expect to be wrong and use it in derivations as if it would be true. If you end up with results that are obviously absurd, then that is a solid mathematical proof that the assumption is wrong. There is no other way in math. The equations derived by assuming that C is invariant in empty space lead to absurd results. Therefore, this mathematically proves the assumption of invariant C and empty space to be wrong. Relativity is proven wrong even by its own equations. There is one theory which states that light is propagating through a medium called ether, and there is one another theory which states that light is propagating through nothing, which is relativity. That is to say, either the ether exists or it doesn't. Relativity works like a mathematical reduction to absurdity that proves the theory of ether right simply because there is no other alternative between them. By proving that relativity is wrong, I simultaneously prove that the theory of ether is right, which is indeed the greatest breakthrough in physics after Maxwell.